Hi, everyone. Thank you for watching our final project video of how to ransom the US astronauts on the Orion spacecraft. So just a quick introduction of Orion. Orion is a spacecraft that's going to be used in deep space missions, such as missions to the moon, missions to Mars, as well as missions to other areas of deep space. So since Orion is such a technically and politically important piece to the US government, it could be detrimental if it were ransomed and unable to be used, which makes it highly likely that the US government would pay a ransom in that case. So this attack tree details the attack that we would do on the spacecraft, which is basically to leverage the supply chain to infiltrate the avionics system and deploy the ransomware. So a couple important components of this. Firstly, the PDU, the power and data unit, is used to control the power to every component on the vehicle, as well as act as a connection between the flight computers, so the VMCs, and the rest of the spacecraft. The VMC, the vehicle management computer, hosts all of Orion's avionics software, which is basically the brains of the spacecraft, which is where we would execute our ransomware. So to just walk through this attack chain a little bit, firstly, we would conduct reconnaissance on all the publicly available mission information, architecture diagrams, as well as design information that's available on the open web. Secondly, weaponization. This is where we would develop the malicious firmware to put into the PDUs. Delivery is where we would infiltrate the supply chain to give a malicious firmware update to hopefully all of the PDUs. The exploitation would start on the PDU and then pivot to the VMC to gain code execution on those computers. And then execution is deploying the ransomware until the ransom is paid.
So this attack makes a couple of key assumptions. We're assuming that we're able to infiltrate the supply chain, which is dependent on having probably a large amount of means. So we're either a nation state, oligarch, or something similar. We're assuming that we're able to compromise all of the PDUs. We know that there are 8 on the spacecraft, so a high level of redundancy, and we do think we'd get all of them. And then we are also assuming that there are limited trust boundaries between the PDUs and other avionics on the system. That said, even if all of these assumptions aren't met, we do still think we'd be able to ransom astronauts. Is this plan viable? We think that it is. There's a high level of engineering documentation that's public, as well as procurement information that's public. We know that there's government pressure to source subcomponents from mom and pop shops nationwide. And we know that Honeywell, who built the PDU, sourced over 8,000 components on their circuit card assemblies. Plus, we know that once integrated, the PDUs are so difficult to replace or repair that NASA has even flown them, knowing that one had a fault in the past. There are a lot of mitigations that can prevent the attack that we're describing, limiting the access to sensitive information to the public. So engineering documentation and supply chain details don't need to be made public. Incorporating risk mitigation protocols, including use of tamper-resistant hardware and trusted boot operations. Leveraging more trust boundaries between avionics and electronics to limit connection between them, and especially connection to the VMCs. Defining whitelists to detail allowable protocols on the electronics, and then using them to detect for onboard intrusion. And then finally, leveraging things like ComSec and encryption keys to make sure that an attacker isn't able to take over communications. So in conclusion, Orion is technically and politically significant to the US, and the astronauts' lives would be at stake in this attack. So we believe the government would pay a ransom. targeting Orion's supply chain appears to be highly viable surface area, and there's reason to believe our attack would be successful. It's vital to make sure that vendors are trusted and that the components integrated into the final product have not been tampered with. And then we can see from this description of an attack that it's important to have security defense at all levels of the system, and that as we implement defense in depth, we can lower the impact and severity of a cyber attack. Finally, of course, this is for fun. The system has already flown, and don't practice any of this at home. Thank you. Bye.